Kia ora Year 12. This problem is looking at the search and rescue task that we'll be doing in class on Wednesday of week 4. So it goes like this. A boat is looking for a diver, and we know the diver is floating somewhere in the area. The boat goes in a straight line, 1 kilometre west and 2 kilometres south from a base to another point, 7 kilometres east and 3 kilometres north from the same base. We don't have any coordinates, so we need to put some in. We're going to choose to make the base at 0, 0, which means the boat is going from this point here, which we'll call A, at -1, -2. And the boat, think of the boat as being chained onto a straight line, so it can't go off that line, and B is at 7, 3. Now, the next part is really important. The visibility of from the boat is 4 kilometres in all directions. So there's my line for the boat. The boat can see 4 kilometres anywhere from any point on that line. But the diver is actually 3 kilometres east and 5 kilometres north. So we'll put him about there. I'd like you to do a sketch as you go with this, a really accurate one, to see what's going on. Our question is, will the boat ever spot the diver? So on the next slide I'm going to look at a strategy to solve this problem. Okay, we've got our grid, which goes like this. So there's AB, and here's my diver up here, somewhere around here at C. So what we're asking is, if the boat is travelling along this line, will the distance from where the boat is ever be 4 kilometres or shorter? Now, we know that the shortest distance from C to a point on that line is going to be where there's a right angle. If you're still not finding that intuitive, try this little exercise. Suppose that the boat is somewhere else. Suppose the boat's where it's not perpendicular. Look how far it is. You can see that you've formed a little triangle with where the perpendicular line is. And we know that this side of the triangle, the hypotenuse, is always going to be longer than this side here. So it doesn't matter where we go here, if we're not forming a right angle between CD and AB, we're not minimising the distance. So the best way to solve this is to say, well, where do we have a right angle between CD and AB? And at that point is the distance 4 kilometres or shorter. So we can break the problem down into 4 steps like this. Step 1. Find the equation of AB. Step 2 is find the equation of CD using the fact that they're perpendicular. Step 3 is find point D, which is the intersection. And the fourth thing is find the length of CD. Is it less than or equal to 4 kilometres? So I'm going to go through that now. So my AB line first. Well, the slope of AB is the change in y over the change in x. A is -1, -2. B is 7, 3. So MAB is 3 minus -2 over 7 minus -1, which is 5 over 8. So we have the equation in this form, y equals mx plus c. We know that goes through point B at 7, 3. So we can substitute these in. 3 is equal to 5/8 times 7 plus c. There are several ways to do this. You can put that into your calculator directly, but you'd want to make sure it was in fractions, not decimals, so using your SD button. But the easier way to go is to multiply everything through by 8. So we'll get 24 is equal to 35 plus 8c. So don't forget to multiply that through there. We get -11 equals 8c. C is equal to -11/8. So my equation is going to be y is equal to 5/8 x minus 11 over 8. Or, two other ways to write that. Let's multiply everything through by 8. 8y equals 5x minus 11. So in elegant form, we're going to have 5x minus 8y minus 11 equals 0. So that's elegant form. However, we are heading towards using this to get the intersection of 2 points. So we need to be ready to have that going into our graphics calculator. So we've got 5x minus 8y minus 11 equals 0. But for our graphics calculator, we'd like it in this form. 5x minus 8y equals 11. Because of how we enter the coefficients in there. So that's the AB line. Right? Now the next step is to say, well, we found that line. Now we're looking for the CD line. We only know one point here, and it's C, but we can get the slope, MCD, must be equal to negative 8 over 5, since AB and CD are perpendicular. So this means that their gradients multiply to negative 1. Y equals mx plus c. The point that we know on the line is 0.35. So we're going to substitute and we get 5 is equal to negative 8 over 5 times 3 plus c. Multiplying everything through by 5, we get 25 equals negative 24 plus 5c, right? Don't forget to multiply that by 5. So now we get 49 equals 5c. C is equal to 49 over 5. So here's our equation in ugly but useful form. Y equals negative 8/5 x plus 49 over 5. In elegant form, we have 8x plus 5y minus 49 equals 0. And in graphics calculator form, 8x plus 5y equals 49. So we've found our two equations. Let's have a look at what we've got on the graph now. We know this equation. This is the equation AB, and that's given to us by 5x minus 8y equals 11. This is CD. This is really not drawn very well to scale now, but C is our diver, and she is at 0.35, and D is here. So this line has equation 8x plus 5y equals 49. So where do they meet? If you are in your graphics calculator, you can go to Equa and then simultaneous, and you're choosing two variables. It's the x and the y. You're going to enter the coefficients. First equation, 5, negative 8, 11. Second one, 8, 5, and 49. Then if you choose solve, your calculator is going to give you the intersection point, and you should get this. X is equal to 5.35 5.0224 and y is equal to 1.764. Or you could do that by hand. I'm not going to do it by hand in this video. Very happy to show you in class if you'd like to. Basically what you want to do is to multiply both of them to get the x coefficients matching up to 40x, and then take one away from the other. So we nearly finished the problem. We've done all the hard work. We've got this pretty ugly looking coordinate, but you can see from your sketch that it looks really good. It looks exactly like where point D should be. Okay, so there's AB. Here's C, and here's my diver here. Sorry, my diver's at C. So all we've got to do now is find the distance CD. So we're going to do Pythagoras on that. So C is at 3,5, and D is the pretty hideous point at 5.0224 and 1.764. So the difference in the x values is going to be that, and we square that difference. The difference in the y values will be, well, you should really go in the same direction. So we'll go 1.764 minus 5 squared. Okay, so with a little bit of simplifying, that equals the square root of 2.0224 squared plus 3.236 squared, which is the square root of 14.5618. Now you can already see before your square root it's going to be a little bit below 4, so that's 3.8159 to 4 dp, which is 3.82 metres, which is less than 4 metres. So the boat can see the diver. Right, that's the end of that problem. Thanks for watching. I know that was very long, but hopefully that has helped you to link up some of the separate ideas in this unit of work.